This is the latest DragonOS Pi64. We're going to take a look at probably about 3 or 4 different things that I've included in here. First off is the GPS simulator here. It's a Qt front end for creating GPS simulations. You most likely need a certain firmware flash to your HackRF to run this, and I'll show you where you can get that and build it yourself, or you can grab the bin file that I've made. We'll also take a look at SDR++ has been updated to 1.0.4, and SigDigger is updated to work alongside or work with a firmware I built for the PlutoSDR that allows the PlutoSDR to run completely standalone and be connected to from SigDigger, and then all the digital signal processing happens on the PlutoSDR's end. And then just know that SDR Angel has been updated to the latest source as of yesterday. So that allows quite a few features. It takes a little while to start up, and I'll probably take care of that in a future build. You have to have a file in place. Anyways, long story. We'll just take a look at a GPS simulator for right now. And yeah, so this is the project page here. You can build the firmware for HackRF that you may or may not need, and then, or you can download. I'll put the link in the description below. I built a bin file already, and I've already downloaded it. And what I'll do is, so I have the HackRF plugged in right now. It's actually already flashed with the firmware, but we'll go ahead and flash it again with a -W. And this is the bin file that I've downloaded from the Google Drive. I'll go ahead and flash that. Give it a second. I'll unplug. Another thing that I have on the HackRF here is an external clock. So I actually have the factory top of the case off and an external clock plugged in to allow this to actually have the precision it needs to work. So if we look in the home directory, you're going to see there's a BRDC file. This GpsSim file won't be there. That's something that will be that you'll create with the simulator. GpsSDR sim is there, and this BRDC file is actually just a copy of the file that comes in the project GpsSDR-sim. We are going to go look in the GPS simulator folder, and because I forgot to do this, we need to edit, let's see, or you may need to edit this, but if you open up your favorite editor, and I'm just using Nano, and we open up the HackRF controller.cpp, I do Control-Shift_, we're going to go to line 105, around about there you will see this line that is set by default, sleep for 1 second. I had to bump it up to 10 seconds to allow the HackRF to reset, so you most likely will have to do this yourself. And I'll fix it the next time. Once you change it with Nano, at least, the Control-O, save it, Control-X. Once you save that, if you go into the build directory and you run make gps_sim_GUI, add a _arm, that will make that GUI or redo it, and then we do run it. So right now I don't have a USB GPS plugged in. If I did, the way that the Pi64 is set up, or the DragonOS, is that it already has the etc default GPSD file set up like this. So if you're using something else besides a USB GPS, you'll have to go in and edit this file. Then when you start up this program, up in the upper right you would see your GPS location. You can also pass different location configuration files by building what it's looking for here. Oops. By default, there's 2 available in the simulator, Houston Radar and Moscow. What you'll do is just decide how long you want to build the sim duration for. It'll go in a loop. Probably a little longer is better. I'm just going to take it down for the purpose of this video and I'm going to generate this simulation, and that's running over here on the right. Over here on the left, you've got the gain for the HackRF, and now once this is done, that GpsSim bin file will be complete, and then you'll be able to run the simulator with obviously the appropriate precautions taken. Alright, so the process time, and it's finished. And so if you hit up here in the upper left, you'll see that it'll pause for a little bit here. So it waited that 10 seconds. You'll see it looks for the HackRF, and then it'll start the transfer. Now if you had a GPS hooked up here, you can confirm everything is working. Alright, so that was just keeping that kind of short there. That's available in the DragonOS Pi64 build. If we take a look at, and that shouldn't really affect much with the HackRF running that firmware. Matter of fact, we can take a look at running SDR++. You'll see now the, if we take a look, if you run it from the command line, you'll see it's been fixed, and so now OpenGPL, OpenGPL is being used on the Pi. Now for the HackRF, I've covered this in the past. You would want to, if you try and start it up by default, I would imagine it's probably going to error out because it's trying to use the SOPI SDR. Alright, let's try this again. If you want to use it with the HackRF, you should just go down to the module manager and remove the SOPI source, close out, we'll run it again. So now HackRF should be fine. And then you can adjust as needed. I have an antenna on it for the not this range, but so that's the latest SDR++ is in there. Let's see, what I wanted to show though is we're going to plug in the PlutoSDR. Now I've got a USB plugged in, but this is a network connection. You could have a USB to Ethernet and then set this up completely remote, but we're just going to do it like this for now. We're going to open up the external storage that opens up when you plug it in. We're going to go back to our DragonOS firmware on Google Drive here. I've got another folder for a DragonSDR firmware I built here for the Pluto. So we'll download this file. Once it's downloaded, you'll copy it into the Pluto SDR, eject the storage, just kind of look up, you'll see the one of the blue lights rapidly blinking. That's the firmware flashing. We'll go ahead and close out of this, waiting for the Pluto SDR to finish flashing the firmware. And what we'll do is we'll look under ham radio. We'll open up SigDigger. First time you open it, it's probably going to look like this. Just right click, maximize. Now the Pluto SDR can be used because it's plugged into the Raspberry Pi. You can use it locally, but we're going to simulate using it through the network here in just a second once it's finished and rebooted. so it's rebooted. What we'll do now is, let's see. I did get this because I had already connected and the keys are not persistent and so on and so forth. But the first time you connect, you'll be fine. You can look that up. It's just because I've already connected and then we reflashed it anyways. So the default password for the PlutoSDR firmware is analog, all lowercase. So now this is a customized PlutoSDR firmware running a few additional packages, RTL433, but mainly I want to show the SCLI tool, CLI tool that's now included in here by default. I've made 3 profiles by default. You can see them here. There's 3, 1, and 250. So what we're going to do is we'll run the dev serve on 192.168.2.1. So that's announcing this on the network. These 3 profiles will be available. So if we come over here to SigDigger, look at our configuration settings, change it to remote, type in 192.168.2.1, and so if we remember, port ending in 1 is 3 meg, 1 meg, and then 250. So we'll connect here first. And so this is coming from the Pluto. It's doing all the work here. You can see I connected. This is running across the network. We can see it keeps the processing rate pretty close, but once you turn on baseband audio preview, the performance goes down a little bit, and there's some audios not quite right compared to if I was running SigDigger on a laptop with a little more power connecting to the Pluto SDR. I'm not quite sure what that is. It just seems something with the Pi64. So, but if we come down here, change it to port 3, we'll see it'll jump to 250 here. You can also adjust the rate of the FFT here for the frames per second. A lot of the features are working with everything running remotely on the on the Pluto SDR itself. So just to show. So you might have to mess with the sample rate and the audio cutoff. Might be able to hear the audio, but for some reason or another on the Pi, it doesn't work quite right. I've tested this profile running on the Pluto SDR itself with a laptop, and the audio was actually pretty good. So, but the point is, you could run the Pluto SDR completely on its own and interact with it. So, I think that's pretty impressive, and I'm sure it's going to get better. Alright, so that was just a quick preview of a few of the things. I know I said SDR Angel is included in here. It's updated. You can run the server portion of it or the front end. It just takes a little while to start up.